solving multiplication and division equations where we focus on division. When you solve an equation by multiplying each side of the equation by the same number, you are using the multiplication property of equality. And again, this is just a really fancy way of saying if we multiply one side of the equation by a number, then we have to multiply the other side of the equation by the same number to keep it equal. So let's look at this with numbers. We know that 2 does equal 2. But what if I want to multiply 2 times 2? Does 2 times 2 equal 2? No way. So I have to multiply the 2 on the right side by 2 as well. And then it will stay equal. So 2 times 2 is 4. And 2 times 2 is still 4. So 4 equals 4. Whatever we do to one side of the equation has to be done to the other side. Let's look at this with an algebraic equation. So we have x over 4 equals 6. Remember that x over 4 is the same thing as x divided by 4. So if I want to multiply x over 4 by 4, then I will multiply 6 by 4 as well. And the reason that I would multiply x over 4 by 4 is to get that x by itself, because x divided by 4 times 4 is just x. So I have x equals, and then whatever 6 times 4 is, which is 24. So right now I think that x should equal 24, and of course let's plug in just to make sure. So does 24 divided by 4 equal 6? Well, 24 divided by 4 is 6, and 6 equals 6, so that's great. Yay! The weight of an object on the moon is 1/6 that of its weight on Earth. If an object weighs 35 pounds on the moon, write and solve a division equation to find its weight on Earth. So what we're trying to find is its weight on Earth. That's the unknown. And we're going to use a W to represent weight on Earth. Now let's look at the rest of the word problem and see what important information we find. I think the weight of the object, 35 pounds, on the moon is important, and that the weight of an object on the moon is 1/6 that of its weight on Earth. So that means the weight of the object on Earth divided by 6 will equal the weight on the moon. Now we already defined our variable, W, and that represents the weight of the object on Earth because that's our unknown. And we have a bar model here that tells us the total weight is represented by the entire bar, and then the weight of the object is represented just by 1/6 of that bar. So our equation is W, the weight of the object on Earth, divided by 6, which we can write W over 6, equals 35. So remember, W over 6 is the same thing as this, W divided by 6. Okay, so now we need to write the equation. W over 6, so W divided by 6 equals 35. And then we need to multiply each side by 6 because we want to get that W by itself. So W divided by 6 times 6 is just W. And then we have 35 times 6 because whatever we do to one side has to be done to the other side. So why don't you go ahead and press pause to solve. So we multiplied each side by 6. 35 times 6 is 210. So since 6 times 35 equals 210, W equals 210 pounds. So that's our answer to that one. Ron ate 60 chocolate frogs in 1/3 hour. Write and solve a division equation to find how many chocolate frogs Ron could eat in 1 hour. So we need to find how many chocolate frogs he could eat in 1 hour. That's our unknown. How many chocolate frogs? So I think that maybe F for chocolate frogs would be a good idea. And then if we look at the rest of the problem, we see he can eat 60 chocolate frogs in 1/3 of an hour. And it tells us to write and solve a division equation. So we need to have a division sign or our variable over a number showing that we're dividing in the equation. So let's go ahead and write the most important words from the problem so that we know, let's see, number of frogs in 1 hour divided by 3 is 60. And then we already defined our variable. We said F for chocolate frogs. So now we need to draw a bar model, write the equation, and then solve the equation. And I want you to do all of this on your own. So go ahead and do this on your own, and we'll check it in your Whisk chat tomorrow.